Our learning goal is I can solve one-step equations. In other words, it's only going to take one step to solve them in one variable. There should only be one variable involved in it, not more than one. We do get to the point where there will be two or more variables involved. And we're going to use multiplication or division to help us solve. What were you doing in lesson 1.2? What was lesson 1-2? What was that one about? Addition and subtraction. Same thing, solving one-step equations in one variable, but that was by using addition or subtraction. Some of you chose not to show work very properly, so you better get on board for that, and I'm going to walk right through it with you here today. So tell me, what are inverse operations? What does that even mean? That's the beginning of our notes here. What does inverse operations even mean? You should know this back from lesson 2. Inverse operations undo each other. So what undoes addition? Subtraction. What undoes subtraction? Addition. Okay, well then what should the inverse operation of multiplication probably be? Division. Division undoes multiplication. And how about division then? What undoes division? Multiplication. So addition and subtraction undo each other. They are inverse operations. Division and multiplication undo each other. They are inverse operations. Okay, so we're going to use the inverse operations of division and multiplication today to help us solve equations. Review. This is important that you remember this, because you're not going to use your calculators to show the work. Okay, so number 1, when multiplying or dividing two numbers with the same sign, so either they're both positive or they're both negative, the answer is positive. Always positive. It is always positive. Same sign, two numbers being multiplied or divided, the answer will always be a positive. Okay? When you're multiplying or dividing two numbers with different signs, so one of them is positive, the other one's negative, or vice versa, the answer is always what? Negative. When one of them is negative, the other one is positive, your product or your quotient will always be negative. And that's important that goes through your brain every time you're doing these. In fact, I'm going to make sure that we ask that question every single time. What should our answer be? Should it be positive or should it be negative? And then the product of any number and its reciprocal. Oh, wait a minute. Well, we better understand what a reciprocal is. Can you give me an example of reciprocals? Okay. 1/3. Okay. 1/3 and what's its reciprocal? 3/1. 1/3 and 3/1 are reciprocals of each other. Give me another example. Andrew. 1/5. What's the reciprocal of 1/5? 5/1. Okay, now somebody give me the reciprocal, or all of you, give me the reciprocal of -2.
2.
Okay, so the reciprocal of -2. Say it like you mean it.
2.
-1/2. -2. If a number is negative, its reciprocal is negative. The reciprocal of 2 is 1/2. So -1/2 is the reciprocal of -2. Okay, how do we know that two numbers are reciprocals? Well, their product will always be what? Or in other words, if you multiply a number by its reciprocal, what will you always get? 1. You better get 1. If you don't get 1, you really don't have reciprocals. So if we would have taken -2 times 2, would we have gotten 1? No. We'd have gotten -4. So they're not reciprocals. But if we take -2 times -1/2, first of all, what's a negative times a negative? A positive. And what's half of 2? Multiplying 2 times 1/2 is half of 2. What is that? 1. So we get a positive 1. We need to get a positive 1 to be able to claim having reciprocals. Well, why are having reciprocals important? Because we always want, when we are solving an algebraic equation, we want our variable to be a 1 of it. So 1x, or 1c, or 1m. We do not want it to be something other than being multiplied by 1. Okay, so let's start solving. We have here c over 8 is equal to -7. What's happening in this one? C is being what? We always look at the side of the variable as long as we want to isolate the variable. What's happening, Devin? It's being divided by 8. So that's the first thought we have to have. What's happening on the side with the variable, it does not matter which side the variable is on, but what's happening on that side? Well, in this case, C is being divided by 8. So how are we going to undo dividing by 8? What do we do? Oh, go ahead, class.
Multiply.
Yeah, we need to multiply. Oh, and by the way, those of you who did not show doing things to both sides of the equation, double underline both. Multiply both sides by what? Not by the reciprocal. Because what is, because it's being divided by 8, so we would multiply by the reciprocal of 8, which is 1/8. Not in this case we wouldn't. We need to multiply both sides by
8.
just 8. What is it being divided by? That's what we're going to multiply by. So we're going to show that. We're going to show that we're going to take 8 times this side. We're going to show that we're going to take 8 times the other side. And we're going to use multiplication dots, not the x, because otherwise we might think we've introduced another variable. Well, 8 is the same as, on that left side, we have a fraction. We have C8. 8 is as a fraction. What is 8 as a fraction? 8 over 1. So in reality, how do we multiply fractions? What happens when you multiply fractions? Don't you take numerator times numerator and denominator times denominator? And then you can simplify after the fact? Or can you simplify, divide out common factors upstairs and downstairs out of a numerator and out of a denominator, and then do your multiplying? So in reality, what happens here is we can divide an 8 out upstairs and get a 1. We can divide an 8 out downstairs and get a 1. 8 goes into itself, both places, 1 time. And that's the goal, because what's 1 times C? 1? C, it's 1C, which can we ditch the 1? Yes. And what's 1 times 1 downstairs? What's 1 times 1 down here? 1. And what happens when you divide by 1? Do you change it up? No. So C divided by 1 is still just C. So it becomes C equals. Okay, now the first thing we're going to do before we even do this is say, I have a positive 8 times a -7. What's a positive times a negative? Negative. 8 times 7? 56. There's our solution. I will let you out of check problems again today. I'm not always going to do that, but one more day I will let you out of them. But if this is the correct solution, what should be true? What should be true? If this is the correct solution, what should be true? Yeah?
That C should equal -56.
Or in other words, if you put -56 in for C, it better make the equation true. Is -56 divided by 8? What's a negative divided by a positive? Negative. How many 8s can you take out of 56? So it is equal to -7. It does check out. Okay. Let's take a look at this next one. -4 equals negative x over 3. Now I need you to pay really close attention here, because that negative sign over there is kind of a big deal. It is making the fraction, the whole fraction, negative. And then we also have going on over here that the x, the variable that we need to isolate, is being what? Divided by 3. Okay, so let's put that. X is being divided by, but you know what? I also want to do one more thing. Because that negative sign is out front, you're beyond this, it's making the whole fraction negative. That negative sign can either be given to the numerator or it can be given to the denominator. Would we want to give it to the numerator? No, we want a positive x, don't we? In the end, don't we want a positive x? So we'll give it to the denominator instead. So let's give this negative sign, just put a little arrow like that. We're going to give it to the 3, and so we're going to say x is really being divided by negative 3. We're going to just give that negative sign. We can't give it to both, so we decide, well, which one would it be better to give it to? And then we're going to do what to both sides to undo that dividing by 3 and that negative sign we just gave to that 3. What should we do to both sides here? Multiply both sides by what? By negative 3. By that negative 3 that x is now being divided by. So we're going to take negative 3 times the left side, and we're going to take negative 3 times the right side, and remember we gave that negative sign to the 3. And why is that a big deal? Because now we can see that these guys really end up, we put this over 1, these guys end up doing this, they divide into each other, or negative 3 goes into the negative 3 upstairs and the 1 downstairs. It's kind of like they cancel each other out. And we have an x by itself over here, because 1x is upstairs, 1 times 1 is downstairs. Again, we have 1x over 1, which is really just x. And what's a negative times a negative on the left there? A positive. And what's 3 times 12? Or 3 times 4? I bet it's 12. Okay. The solution is 12. Okay, you want to ask me questions? Anything about that was confusing? Because now we're going to sub it in and see if it works. If I put 12 in here for x, I go back to the original. By the way, whenever you do a check problem, again, hear me on this. Whenever you do a check problem, you have to do it in the original problem before you did a darn thing to it, before you did anything to it. So it originally started, negative 4 equals that negative sign, x over 3. So we're going to put 12 in for x. What's 12 divided by 3? 4. But then we still have that negative sign right here, and that negative sign says, you know what? I can be also read as the opposite of. So what's the opposite of 4? What's the opposite of 4? Negative 4. And that's what's on the other side, negative 4. So it does check out. So no questions on that? Let's put some so that you kind of keep these two problems separate. Let's put a line or something in between here to divide these, show that we really have two problems going on there. Okay, then let's go to the back side. And let's try some more. Let's take a look at the first one there. Negative 15 equals 4y. Y is being what? Let's look at the side that y is on. Being multiplied by 4. Now you don't have to write all this stuff out in your homework, but these are the thoughts that should be going through your head while you're doing your homework. Oh, it's negative 15 equals 4y. Y is being multiplied by 4. So then what should I do to both sides to get y alone? What undoes that multiplying? Dividing. Dividing by what? Dividing by 4. Okay, so divide both sides by 4. Tell me what you get. Now, I know what a lot of you are already going to do. You're going to just stick the 4 right underneath there like that. Rewrite the problem, because then you can see what was it to start with in the beginning before you started working with it. Well, over here, these 4s divide out, don't they? And we end up with y by itself. What happens when now we have a negative divided by a positive? What's a negative divided by a positive? Negative. Always. One's negative, one's positive. The answer is going to be negative. Does 4 go? Can you take a nice number of 4s out of 15? No. So how many can you take out? 3. Okay, after you take 3 4s out of 15, 3 times 4 is 12. How many pieces are left? 3. 15, take away those 12 is, so we're going to have negative 3 and 3/4. That's not a very good job with all of my writing here. I'm going to get rid of that. Is that a nice decimal?
Yeah.
Yeah, it is. This is a nice decimal, so you could say or -3 and what? 0.75. Or, guess what? There may be another way you would even see this answer in an answer bank. Oftentimes in algebra, instead of changing them to their mixed number or their decimal name, they will leave them as improper fractions. So can we simplify -15/4? Or in other words, is there anything that goes into 15 that also goes into 4 other than 1? No. So we could also leave our answer as -15/4. So we have all kinds of options here for the name for this. We have, that's another option, that's another option. We have 3 options. We have 1 solution, but 3 options for how that name could be written. Why can it be written as a decimal?
It's
A nice one. What does nice mean?
Stars.
It what?
Stops.
It doesn't repeat, it stops. Yeah, it doesn't repeat, it stops. We call that a nice decimal. Okay. Let's look at the next one. This is the one that's always interesting to me. This is when I know you guys are so calculator dependent. -2/3 m equals 6. What's happening? M is what? Being multiplied by 2/3. Okay, so it's being multiplied by 2/3. Well, how do we undo multiplying? We divide. So here's what I will see on students' papers. Watch. You do not need to write this down, but just watch what I write. Because this is what I will see. Because you're absolutely right, aren't you? You undo multiplying by dividing. So I say, oh, I got to divide both sides by -2/3. Well, I already know that you're really smart, and you know that that positive divided by that negative is, first of all, a negative, right? But I'm a little bit not certain that you can tell me how many times you can take 2/3 out of 6. Anybody just happen to know how many times you can take 2/3 out of 6? So if I had 6 holes, and each of those holes was divided into thirds, how many times would you be able to pull groups of 2/3 out? That's basically what 6 divided by 2/3 means. Do you think you know, Kate? 6 times? So, okay, go ahead, Josh. 3 times. So you guys are helping me make my point here right now. You do not have any idea, do you? So if this is how you show your work, what am I going to have to assume you did? Okay, yeah, I got the calculator. Okay, let the calculator do it for us. Let's just see if it's 6 or if it's 3. 6 divided by 2/3. Don't worry about the negative sign right now. We've already decided the answer is going to be negative. How many times can you take 2/3 out of 6? Because I'm going to disagree with both of the people who said something. How many?
9.
9. 9. Huh. How is that possible? Well, 2/3, is that less than 1? Yeah. So if we're taking less than 1 out of 6, how many times? Well, less than 1, less than 1, less than 1, less than 1, less than 1. It's 6 times. We still have some stuff left over, don't we? Yeah, we didn't, it can't be just 6. We have a third left over, 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 and a third left over. So now we got to bring all those thirds together. Well, I got 3 of them right here. That'll be 1 more. Or excuse me. We're taking 2/3 out. I got to take 2/3 out. That's a 1. Another 2/3. That's a 1. Another 2/3. That's a 1. Oh, wait a minute. I get 9, not 6. So we are not going to show our work this way because we do not really truly understand that you can take how many 2/3 we can take out of 6. We instead are going to multiply by the reciprocal of -2/3. What is the reciprocal of -2/3? -3/2. Flip it. If it's a negative, its reciprocal is negative. So -3/2 times -2/3 m, -3/2 times 6, and I'm going to make 6 into a fraction by putting it over 1. This is how you're going to show your work because you're not really going to let your calculator do it. Your calculator isn't the one who needs to learn. Well, when we take a negative times a negative, what do we get over here? A positive. And what happens when you take a number times its reciprocal? You get 1, don't you? So we get 1m. So guess what? This took care of, that took care of what we needed it to do. We have m by itself now. Right side, where our solution is going to be a negative times a positive is a negative. We've already said that. Well, we have two choices. We can simplify before we multiply these fractions or simplify after. We already know the answer is 9, right? Negative 9. But, so, how many of you are used to doing this? 2 goes into itself 1 time. 2 goes into 6 3 times. Yeah? No? Maybe not? Okay, well, the other option we have is just multiply straight across. 3 times 6 is? 18. 2 times 1 downstairs is? 2. 18 over 2, what does that simplify it to? 9. Or we could do it my way and then say 3 times 3 is 9. And 1 times 1 downstairs, we don't need that because anything over 1 is still itself, so m equals negative 9. Now, again, you don't have to, you could have instead done this, negative 3 halves times 6 over 1. You could have said, oh, that's negative, and it's 18 over 2, and that does simplify to negative 9. We get the same thing, okay? It's just how did you learn to multiply fractions? Questions on that one at all? Okay, then our last one that we're going to do, let's just put a line here, showing that we're starting a new problem. Okay, we have negative 5x over 6, and that is equal to negative 2/3. Okay, all kinds of fractions going on in this one. Well, here's what we're going to do first. We're going to pull, if anything that is in a numerator that is a factor, if it's part of a multiplication problem, like that x and that negative 5, they are part of a multiplication problem. You can pull any factor out of the numerator, the upstairs, that you want. You can't pull out of the downstairs, but you can pull out of the upstairs, okay? So we are going to rewrite this as negative 5, 6, and remember the negative sign? If it's in the numerator, it can come out front. Just like if it's out front, it can go in. So we are going to rewrite this problem as negative 5, 6x equals negative 2/3. Okay, what do we need to do now to both sides to solve this? What do you think? What would be a good choice here? Katie? Divide by the reciprocal or multiply by the reciprocal? No, if we divide, we actually divide by the actual. So if we're going to change it into, instead of dividing, we're going to multiply by the we need to multiply by the reciprocal. So what's the what reciprocal? Of the negative 5, 6, so that's negative 6/5. We have to make sure that we don't do the reciprocal of the other side. So negative 6/5 times negative 5, 6x. Negative 6/5 times negative 2/3. So in other words, the equation still looks the same. All I'm doing is multiplying both sides by negative 5, 6. Both sides are getting multiplied by the same thing. Okay, go ahead and finish that out, see what you get. Okay, let me hear some of the answers. What'd you get? Devin, what'd you get?
X equals negative 4/5.
Negative what?
4/5.
4/5. Okay. Anybody want to agree with him? Andrew, Austin, TJ, Braden. Okay. Somebody else want to offer up an answer to that? Go ahead, Shane. X equals what? Positive 4/5 instead of negative. Anybody want to agree with Shane? Oh no, Devin is even backing out on himself. Oh, and so are your constituents. They're backing out on you too. Why is it positive instead of negative? to take a negative times a negative. Okay, so yeah, this isn't the right one, is it? We have to have a negative times a negative is a positive, first of all. And then how do we get 4/5 out of that? Devin?
You reduce, reduce the thing. I did reduce the multiplication before I.
Oh, you do the multiplication before? Okay, so then you got 12 over 15. Okay, and does 12 over 15 simplify to 4/5? Yes, it does. Could we do this? I'll use a color. Could I say 3 goes into itself 1 time? 3 goes into this 6 up here 2 times? And then is 2 times 2, 4? And 5 times 1, 5? Okay. But in the end, what should our final answer be? The simplified version of 4/5. Yeah, x equals 4/5. Okay. So, in other words, if we would have instead said, you know what, here's what I will see on some papers, I already know it, I just know it, I'm going to see this, I'm going to see this, and I'm going to be like, really? You can tell me how many times you can take 5/6 out of 2/3? Really? Do you think you really can? Well, apparently you can take it out 4/5, less than 1 time. 4/5 of a whole. I don't think you probably are thinking like that, so we can't say this, because then again, what's doing it, I have to assume, if this is what I see, what's going on? Calculate it. Unless you can show me, you're like, you just stand there and you say, I can tell you exactly, I throw a problem at you and I say, tell me what, 4/7 divided by 1/3 is. And you can say, I know how many 1/3 I can take out of 4/7, and you talk me through it, I'll be like, cool, you got it. You don't have to do the multiply by reciprocal thing, you got this figured out. Okay, so any concerns? Okay, let's get to work on your homework then.